Today we're going to look at Hooke's law, which provides the relationship between the force of a spring and the stretch of a spring. We're also going to look at areas when this relationship essentially just breaks down. So let's start with a spring. According to Hooke's law, the force from a spring is proportional to the displacement given to the spring, or the stretch of a spring. In the form of an equation that is F equals K times X, where F is the force, K is a constant that is specific to the stiffness of the spring, and X is the stretch or displacement of the spring. However, we actually just put a negative sign in front of this equation, and that's because as you stretch a string farther and farther out, the spring is going to want to return to equilibrium, or where it originally started. So that means the force will be in the opposite direction of the displacement. So now let's look at a graph of just the scalar quantities of force and displacement. So without taking in account the direction, and we can rename these as stress and strain. Now, there's a point where this relationship between force and displacement doesn't really work anymore, because a spring will not stretch on forever. It will eventually start to deform and break down. We can use a toy slinky as an example. So let's say you were to stretch this slinky more and more, and you would eventually get to a point known as the proportionality limit, where the force no longer scales linearly with displacement. So, stretching this slinky even more after this point will no longer create as much force as before. Now, if we keep going, we reach a point called the elastic limit, and this is the point where we've stretched so much that the slinky will no longer return to its original shape. Now, beyond this point, the slinky will start to exhibit what's called plastic behavior, meaning that any further strain on the slinky will simply deform the slinky permanently. As an example, the slinky might develop cracks in its mechanism. Furthermore, by putting this poor slinky through even more strain, the slinky will eventually just fracture. And as a result, we will all be sad that the slinky is no more.